Hey everyone, really excited today to talk a little bit about trace and metric processing, and kind of go through that, how we work with it in Calyptia. So with further ado, let me go ahead and share my screen here. Okay, excellent. So today what we're going to talk about is a little bit of an introduction for those who potentially don't know what Calyptic Core is, what it's based on, how it works. We're going to be very demo heavy during this webinar, so we'll spend quite a bit of time in the product, talking a little bit about how some of the processing works, talk a little bit about some of the updates that we've made to make trace and metric processing that much better. And then we'll get into some of the use cases and of course leave some time for Q&A. So we'll absolutely have a good amount of time to kind of run through the entirety of the presentation, metric trace collection and whatnot. So a little bit about me. I'm one of the maintainers of the FluentBit ecosystem. I've been pretty active in the Fluent community channels. I generally work a lot in the logging space. So you might have seen some of the stuff I have with logging and how that works. And more recently, as we've added these features in, started to jump into things like, hey, this is how much tracing or processing or how much metric that we can also accomplish with FluentBit. So for those aren't aware, a lot of what we've built around the Calyptia product set is around the FluentBit ecosystem. And so FluentBit, as it has been tremendously driving up in the past 2 years to multiple billions of Docker downloads and used by many of the hyperscalers, large hardware providers, and clouds. It is something that's very very important to make sure that it continues up in that ecosystem, providing world-class logging support. And then on top of that, from a telemetry side, as we standardize more on things like OpenTelemetry, Prometheus, OpenMetrics, that it can play very, very well within those ecosystems. So something that sits adjacent to those strategies as a part of that strategy. How do I do trace collection? How do I do metric collection? How do I do processing of that? And bring it all into the ecosystem. So really, if we look at like some of the problems that we see today with just a lot of the telemetry data management that's out there, is there's a ton of different ways to bring about these systems. You might be leveraging, say, something for logs, something else for traces, something else for metrics, perhaps some Kafka sprinkled throughout. And as that has continued, or as that complexity grows, it becomes hard to really change or modify or understand how any of this could potentially be optimized. So that's really where, from a complexity and data management side, this is where we see a lot of folks struggling or looking for ways to go do that. Now, the nice thing about the Calyptia aspect is we don't just sit as a FluentBit drop. We are really a end-to-end pipeline. So something that looks at the collection, going to the operating system, going to the kernel level, grabbing those particular metrics, even generating it in a format that we know and perhaps love, like Node Exporter, and then bringing that into a pipeline that can do a bit more centralized type of collection, processing, routing, redaction, and then of course firing that over to the particular backend. Now, in our last session of this webinar series, we talked a lot about log processing, and I'll slightly touch on that again today. But also we're going to really focus in on like, hey, I have metrics and log-based metrics and traces, and how do I go about doing that, and very specifically about OpenTelemetry. So let's go ahead and jump into a little bit of the collection side. So how do we look at metric and trace collection with Calyptia today. And I'm going to go ahead and open up my Calyptia console here. And you'll see here I have one core instance that's attached to my Calyptia management plane. And this is running within my essentially Kubernetes environment. So one of the great pieces here is whether I have Kubernetes or in this case I have an EC2, I'm essentially running this data processing plane as close to the data as possible. So I can receive data within my VPC, within my project, within my account, and do that without much trouble. So this is a core instance that's running in the account with a couple pipelines that are attached. So let me go ahead and click into this. You can see I have some data pipelines stood up. And maybe just to even illustrate a little bit of, hey, what does it mean to actually have a pipeline? We'll just do a quick test pipeline to show what this means. The great part of Calyptic Core, for those who might not necessarily have as much familiarity, it has automatic load balancing. It does things like persistent retries. It collects metrics about how it's performing. And so all of those things, trying to take best practices of running something more centralized, something more geared towards collection or processing for this this type of application. So in this case, I have a service type load balancer. I'll keep that as is. I'm actually not going to even open up a port. And then from a source side, we'll go and choose a source. So I'll choose something a bit more fun, like, hey, I want to go grab some logs, metrics, traces. Maybe I'll generate some traces just so we can see what that looks like. And then from a destination side, standard output. So I'll click Save and Deploy. And we'll click into this pipeline, and we'll be able to start seeing what those logs look like as well. So right off the bat, creating some pipelines. These pipelines are independent. They have their own scaling, secrets, persistence, load balancing, all of these attributes that are typically part of that. And here I've gone and generated a trace. And because we're compatible with OpenTelemetry, we're taking OpenTelemetry input and we're just printing it to the console here. So here I'm generating this span that's saying, hey, I'm doing work. And you can even see that it's represented in a true OTel format type of trace. Not OTel JSON, but OTel OTLP, if you will. So this is generating this trace. We're printing it out as a trace. So we can see, hey, if I'm sending a bunch of traces, what this could look like if we want to just view and understand it. So now what I'm going to do is I'll actually add another one of these inputs, but instead of it being at the trace level, we're going to add it at the metric level. So we'll add another source here. This time, instead of logs, we'll choose metrics. Save and deploy. Okay, excellent. Looks like that's updating, starting right now. And similarly, I'll get the latest logs. And when we think of metrics, one of the easiest ways to represent those metrics is through Prometheus format. So now, in addition to that span that's coming in as an OTel span and trace, I have now a set of Prometheus metrics that are also being generated. Now, the plugin I'm using is this kind of data gen, automatically generating some data for us. So that's why it's showing up as like, hey, where did we actually get this Kubernetes network load counter? What is this? What's happening? What's going on with this type of data type? So you can see here, this is just randomly generated data. And next, what I'll do is I'll add some logs into the mix. Now I can add the same dummy logs, but sometimes it's fun to live on the edge, and maybe we'll grab some Kubernetes events, which we'll treat as logs instead. And so we'll save that. And now, in addition to the the traces, the metrics, we'll also start to see the logs as well. So the metrics. I'm assuming it's taking just a little bit of time to go grab all of those Kubernetes events. Let's give it another reload here as well. Give it just another couple of minutes or so. Now that we see, hey, this is at the 12 with 6 seconds. Let's try one more time. Still nothing here. It's all good. Your typical webinar demo demons. Potentially something that's going on with the pull of the going on with the pull of the internal Kubernetes API server.
Hey, Anurag, we have a question.
Yeah, absolutely.
The question is, does the OTel collector unnecessary in this paradigm? Or are there cases where you'd still want to have an OTel collector?
Ooh, that's actually a good question. So with Calyptia, you might have seen when I opened up the sources before, we are really meant to be something that can integrate very, very quickly. So going back to how we typically plug in, you might have a large set of existing agents, and it can be particularly troubling, or I shouldn't say troubling, but it could be time and expensive to go try to replace all those things with whatever agent you might want to be using, whether that's Fluent, whether that's OTel collector in agent mode. So instead, what we want to do is be able to plug into that, whether it's Splunk, whether it's Heck, whether it's Beats, Logstash with Elasticsearch HTTP, Datadog agent, Telegraph, and similarly with OTel collector, we can receive OTel. So whether your applications are instrumented and you want to keep using the OTel collector, cool, no problem. Or if you want to just go directly into here, you can do that as well. So we can open up another port. This will be load balanced. Everything deploys as a blue-green deployment. That same level of persistence, retry, all of that is automatically configured. So there's certainly benefits compared to maybe the raw open source experience you get. But if you're already using it and you're worried about having to replace everything or drive a lot of change across an environment, certainly, can receive from that as well. Oh, and I'm already using the port 8088 because I'm deployed on a VM. So instead, we'll choose a different port. We'll do something like 8090. Excellent. Okay, so now we are generating a bunch of traces. We're generating a bunch of metrics. We opened up an OTel port on this test pipeline as well, and it will go and craft its own endpoint for us. And we're just printing out everything into standard output for now. So nothing too crazy here. Really just collecting the data, grabbing it, and basically writing it to standard out. So what I'm going to do now is talk a little bit about receiving symmetric data. So you might have seen as well within the source side, there is scrapers. So we can scrape from Prometheus endpoints. We can, of course, receive from OpenTelemetry endpoints. And if you have particular logs, you can do some changes within the processing side as well to generate some log-based metrics. And so that I'll start with log-based metrics. Then we'll talk a little bit about the OTel format, and then we'll talk about processing for all of it. So let's talk about log-based metrics first. So as an introduction to how Calyptia works and how processing works, effectively what you're seeing here is a screen meant to be extremely fast to go iterate, build, and deploy on top of. So for example, here I have a set of log lines. And if I do a quick run, I can see what these log lines will look after it gets processed in the pipeline. You can see it automatically schematizes it with a key of log and a value of line. When we send it to a particular endpoint, we can keep that type of transformation. We could also modify it. We could change it. We have a lot of ability to do some of those different things on. The other thing you'll notice is that I have actually different telemetry types up here. So I have logs, metrics, and traces with just a numerical count for how many actions that I have. So let's start with logs first, and we'll do some stuff here like, hey, we want to add, I don't know, a region of hello. We'll add a comment for some good code practice, and then we can test out what this actually looks like here. So awesome, I'm able to add the region. I can add that to the log message. Things are looking good for us from a region and everything. So let's go do maybe something a little more complex. Maybe let's go do a redaction, for example. And here, maybe within the log, I want to keep the numbers, but I don't want line. Let's say line is something proprietary, so redact first part log, just as a comment again. And if I run that action, you can see, hey, we are now actually taking that out and not necessarily using it. Next, we might want to do some things like aggregations, or I might want to extract that number. Now, 1 through 10 is pretty boring, so I'm going to import a template that we already had on aggregations. So open that up here. So this is a JSON file that comes in with a name, someone's profession, and an age. And within our aggregation side, and sorry, actually, right before I jump into the aggregation side, you can see that age is already parsed as a number. And you can know that by, hey, there's no quotations around it. And I'll turn off the aggregation just to show you, hey, each of these records here's the age that comes into it. We can do calculations ad hoc here as well. So maybe we want to say, here's a custom rule, and I'm not the best at Lua, so we'll use some of the features that we have within Calyptia to help write these processing rules and say, add a new field, super age, and age. Have it generate so that way we can see. So it'll check if this record age exists, and if it does, it'll craft a new one, super age, that we can use. So let's try that. Great. So here's a super age, which is 20 of the particular age. And now we have a new record that is generated from that. So processing for like a metric, we can even just do something like a log-based metric, immediately do some small calculations. And obviously, because it's a full scripting language, if you want to do something complex, you have all the ability to go do that. So next, I'm going to do this aggregation, but I'm going to do this after the subtraction. So I'm just going to move it down. And from here, I'll go click Edit. We'll do a time window of 50 records. We'll select the key on which we want to aggregate. We'll do it on top of the profession. So we perhaps want the super age of the profession. So we have this calculation of average against age. Maybe we'll change that to super age instead. We'll turn it on. Oops, turn it on. And there we go. Here is the calculation for the super average age of the super age. And if we want, we can even add another field here as well. Average, let's do age here. And that looks good. And perfect. Now we have count, we have average age, we have average new, and we're doing some calculations with it. So this is still in the context of logs. So from a metric processing side, it's metrics within logs. How do we go and mess with something like that? And now what I want to do is talk a little bit about the metrics and traces. So you'll notice as I swap into these different tabs, I have no processing rules. So what we've done with Calyptia is we said there's a ton of really good high value processing that is available within the log side. And we might want to do some of this same thing on the metric side. We might want to do some of the same thing on the trace side. So one thing that's really important to note is what does the actual schema that we receive look like? And we try to align ourselves really, really closely with OpenTelemetry from a metric and trace side. And we can leverage the schema that OpenTelemetry has when we want to do some of these additional type of computations. So I'm going to open up the GitHub for OpenTelemetry that has a lot of the particular metric examples, trace examples, and here's, say, a JSON representation of a service with a counter, a gauge, a histogram, and you can see this is a pretty large JSON type of metric. So for today, if we want to go do some of these transformations, maybe add a label, remove a label, do some of that. The way that we do it in this interface for just testing it out is primarily through pasting in that JSON record and doing some of those individual transforms. Now, the good thing is I'll just close out of this. We'll go and edit the one that has metrics. So we'll go back into the metric side. And on the metric side, I'm going to import in let's do a add label. So we're going to go and add a label into the specific Kubernetes particular field, and then we're going to delete some keys like hostname, the hostname label within that. And actually, just instead of modifying this new pipeline, let me cancel out of here. Let's go to test metrics. Just to keep things a little clean, this one already has just metrics being generated. Nothing too fancy. I will go ahead and edit the metrics. Let's actually just turn this off for now. We'll delete these so we can just see what the raw metrics look like. And then we'll come back in and insert the processing rules that we have in place. Getting the logs, getting the output, we should say, because hey, these are actually metrics that are being generated. And here, this is only the test metrics of those Kubernetes side, right? Kubernetes network load counter. I have two labels today, app C metrics. I have this hello world, probably still old from the previous one. So I'm just going to reload so we can see it clean without that any of these label changes. And yeah, great. So now when we look at the network load counter, you can see I just have my host name and app. I don't have that hello. So now we're going to go add those rules to do the transformation or the addition of those labels. So we'll come into processing rules again. We'll do the import of the add label. And we're going to, maybe we'll keep the host name delete off. We'll just do the add for now. So apply that, save and deploy. That's not the pipeline we want. We want test metrics. Let that load. Hopefully it's restarted. Yes, it has. And leave. This is still the old version. Let's do another reload here. Okay. I'm still doing a reset. Just one quick check on my side. Looks like I set here. Give me 1 second to log back in. So did a quick update on that version, which was showing the previous version. So we changed it to 24.5.2, which supports all the new metric and trace processing. And now, if you look at it, there is our new label of hello with our host name still present. So now let's go do the same thing with the delete side as well. So here, we'll turn these things on. So we'll delete the host name label for the counter, and we'll delete the host name label for the gauge as well. And similarly, we'll have to adjust the version here as well. Do a quick reload here as well. Perfect. And it looks like it restarted. We do a restart here, reload. 680. So now we get to see how does it do a restart here automatically. So the underneath the scenes, Oldest is driven with an operator. So it'll go look to say, hey, I need to make sure that everything is up and running or healthy, and it will go and try to modify the desired state here for that. So one of the nice things of being built on Kubernetes is those are some of the ways that it tries to do all of that by default. And so it'll go try to auto heal itself or understand, hey, what happened with a particular issue? Let me get back to a status of running. So looks like I think it did a quick restart. Let's see if that did it. Well, looks like it started. Still waiting for some printouts of log messages. And I'll do another reload here. As well. And I'll just go do a quick modification of these delete keys. Let's just do one of them at a time, see what's going on. So we're back to just grabbing the host name, grabbing the app, and then getting rid of the hello in this case. So let's look at how we do the same thing with traces, for example. So we'll go back to pipelines here. I'll create a brand new pipeline here called test traces. We'll keep things load balancer, and we'll just do one at a time. So again, instead of doing logs, we'll do traces here, and then we'll just do quick standard output, save and deploy. And wait for that to go here. Let's get latest logs here. And we'll get the same spans that we were getting in the beginning. Do another reload here as well. Perfect. These are the internal metrics for the pipeline as well. So it's showing things like, hey, how many records are coming in, how many are processing, and how many are being output. So now what we'll do is we're going to go do another import. So this time, instead of importing on the metric side, I'm going to go ahead and import into the tracing side. So let's go and we open up a new template. We'll open this, import from here, and I'll just logs metric 0, but trace 1. I'm going to drop anything that includes a span called main. And then I'll also set name to processing rules. So I'll be able to take similarly to this metric that comes in as like that big JSON array. Our traces are going to be represented in this format, which we can then go and adjust or modify specific pieces. And then from there, we'll be able to do the same type of transformation. So in this case, for example, hey, we're going to block a record that has the name of main, and then we can also add some additional values on top. So we'll apply this, and we'll save and deploy. Okay. You can see our span has been adjusted now to say processing rules. And if there is a span that contains main, which was one of the other spans that was being generated, we're just dropping it. So now we're doing 2 pieces. One is adjusting pieces and still having it represented in OTLP format. So these traces can go to anything that supports OTLP. And second, we are also doing dropping or reduction of a particular trace based off of a value within, say, a span. So really great to have the ability to kind of say, hey, I want to do a reduction, I want to do a redaction, I want to do a modification. And one of the things that we are working on even more is we understand that there's a lot of different formats with OpenTelemetry, and I'll be one of the first to admit I even run into challenges, as you could see as I was trying to get the Prometheus pieces into an OTel metric format to do the modification. So one of the nice things within our builder is this immediate feedback for what a log or metric or trace type processing side will look like. And so right now, today it only shows raw and JSON, but we'll be adding things like Prometheus and OpenTelemetry, so you'll be able to also check from that angle as well of, hey, if I paste in my OTel data or my Prometheus data, I can also do some much more fast real-time checks with those pieces as well. So that's a little bit of the metric and the trace processing. How does it work? I think from an architectural side, one thing that's always useful is understanding how does processing even work here. And so, for example, the way that we go and do this processing is by taking in data to, say, a specific port. And this is a log processing, but traces and metrics work the same way. Oops. And it will route it to or load balance it to multiple pipelines. So each of those pipelines that I was showing had a replica of 1. You can imagine that I might want to do 5, 6, 8 if I have a huge volume of, say, traces, huge volume of metrics coming in. And this gives us the ability to go do that. You can do things like tolerations, tains, pod rollouts, customize the service ingress if you have your own way to go do something like that. We do try to automate or make as much of this available as possible.